Good morning, everybody. It's my pleasure to be the coordinator of the first scientific day in the Mechanical Engineering Department at the American University of Mádba, and it's even my greatest pleasure to have hosts like Dr. Ayoub Abdiye and our friends from Friedrich Eibert, and to participate in this day. This day will be only successful if our beautiful students will also participate. Actually, part of the activities that we have will include sessions from presentations from students, and we hope that other departments will follow. We have a very rich day today because we will start with the presentation from a Jordanian figure about energy and environment. He is actually the chairman of the Energy and the Environment. I will leave the introduction to the proper channel people, but we just mention it. And this part of the session is actually sponsored by the Friedrich Eibert Institute, who are so graceful to give us also, they're going to present us with some gifts from certain publications of them. And they have a brochure. Please, everybody who would love later on to have a copy, please let them do that. Also, we have a very beautiful presentation, very unique, from our dean, Professor Karim Numer, who will talk about three-dimensional panels, which is a very new idea and can also save energy. That is relevant. The students will be talking about the presentation about the potential of alternative fuels in vehicles in Jordan. We will have also some presentation from very much of a Jordanian entrepreneurs who invented and presented something called PeopleBad that will transform any flat service into a smart board. And this is portable. We'll hear about their presentation. And my humble self will do some presentation about what I know best, which is the solar energy. But first of all, let me welcome Professor Karim Numer, the Dean of Engineering, to give the opening, the startup of the first day.
Thank you so much for this warm welcome. I'm so glad to be with you this morning. I'm so happy to see all of you this morning with this theater full of our beloved students. So on behalf of our dear students, I would like to welcome Dr. Ayoub Abdiye, a winner of several prizes and trophies. One of them is the Green Apple Trophy. Also, everybody knows that Professor Ayman Maaita is a winner of the Emirates High Honor Trophy, and also His Majesty King Hussein, the Royal Highest Honor Medal. Also, I would like to welcome all our faculty members, Dr. Munther Nimri, one of the founders of this university and the ex-dean, your chairman, the chairman of the Mechanical Engineering Department. First of all, I would say this is the first event, the starting event for many events to come, many activities next year. First one will be to participate in a competition in a green building in Mádba, which we will have to participate from all engineering departments in a competition related to green building. It's a social center that is a contribution from the Hashemite Fund. Students from different departments will participate, from architecture department, from civil engineering, from mechanical engineering mainly, because it's on green building, as I said. A second event will take place next year. We probably or most likely will host the graduation project competition of Jordanian universities. Third event would be to have a conference probably on renewable energy and probably structural mechanics and other fields in mechanical engineering. One other event will take place that is anyhow, I would say that engineering is the art of making it happen. Without engineering, I would say it's hard for anything to be in operation. Engineering goes in many fields, and good engineers who are capable of mapping the imaginary complex plane of spirituality, values, ethics, instincts, into the real plane of engineering, of the Faculty of Engineering at AUM. As you know, AUM is following 5 main pillars. As a Catholic-founded university, we are associated directly with spirituality and values. And you know, this university is founded for a good cause. It's founded for a good humanitarian cause. As an American university, or before being an American university, I have to mention it is a not-for-a-profit university. Not-for-a-profit university means a lot. The money that goes in stays in. And this will make it possible for AUM to launch, to take off very fast. Because everybody knows that without good financial support, without a good budget, the university cannot be sustained, cannot nourish. Again, it's an American university, which is very important, and it is a challenge for every one of us to have the university an American-style university, to have the campus an American-style campus. Also, it's a Jordanian university, and Jordanian universities are known for being on the top, and we should be proud of our Jordanian university, especially public university. And also, it's a private university. You have to be able to maneuver, and you have to be able to move on without governmental restrictions. If we can map AUM, and if we can map the Faculty of Engineering, which is seeking excellence, sustainability, and being distinguished not only in the local and regional level, but also on international level. If we could map the ethics of the complex plane into the engineering ethics. And I concentrate on engineering ethics. Engineering ethics means a university that is free of cheating. A student that cheats in the exam would not be an ethical engineer. So we start by resenting cheating in exams. This is one major thing we have to be careful about. And I always hope for having the honor system in our exams. You just have to do exams without anybody watching you. We have to respect each other. We should resent talking in the classrooms. I believe, and those guys at the end, they are laughing, because I always tell them talking in the classroom is something really bad. In American universities, students don't talk in the classroom. This is another reflection of spiritual values into the real plane of the university. Again, we have to know how to work together, the teamwork. The teamwork is still something we do not understand perfectly. A teamwork, and when you are given a project, it's not one guy do the whole job. Everybody should participate. And we have to be able to do teamwork if we first can accept each other's, if we can respect each other's, then we can work together. And it is important to work together even of our differences, regardless of our differences. I thank you so much, and I welcome you all, and I invite you all, especially my dear civil engineering students, to come to the structural system. It's an energy-saving system. It's a reinforced concrete system. You should be interested in it. In addition to all lectures are very important for everybody. Welcome you again, and thank you so much.
Thank you, Dean Nomer. I think probably he could not resist transferring some of his wisdom and experience to the fresh students. Thank you very much for this opening. And now I call for Dr. Mudar Nimri for
صباح الخير. I think I will take 1 minute to allow everybody else to talk about the important issues here. Welcome all to the American University of Mádba, to the first Mechanical Engineering Scientific Day. And it is a real great pleasure to see all our students here. And I would encourage all of you, I know you all have lectures, but I would encourage all of you to stay as long as you can and to come to all the lectures. Thank you very much. Welcome, Dr. And welcome Kaswani here, and welcome all to this beautiful day. Thank you very much.
Okay. Thank you, Dr. Munder, again for the quick speech. Anyway, let me call to the podium Dr. Ayub Aboudiye, as Professor Numair has mentioned, he's a well-known Jordanian figure, public figure actually, in the field of energy and environment. He is a winner of multinational and international awards, including the Green Apple, and lately he won the Arab National, جائزة الداعية العربي للبيئة, the Arab National, داعية البيئة العربي. So without further ado, I will sit and watch this important presentation by Dr. Ayoub about the energy crisis in Jordan. Thank you.
صباح الخير لكم جميعا. It's a pleasure to be here today at the invitation of the American Jordanian University. I'm glad that you are all here. My presentation today will talk about the energy crisis in Jordan. Therefore, I shall start by asking some lights to be put off from the podium, please, from this room. Can somebody help me to put some lights off so we can start with saving lights in Jordan? Just some lights that we can, this would be an example. Wherever I go, I never start talking without switching off some lights first. So you can do that at home, you can do that in your lectures, and it can be, أيوة بس منيح هيك؟ لا هيك عتمة صارت. طيب لا خلي شوية ضوء. لا خلي شوية ضوء. ايوه الضوء اللي على الجنب هذول ممتازين. ايوه شكرا. طيب. So that's how we should approach the issue of energy crisis. I usually say we don't have an energy crisis in Jordan. We have a management crisis. We don't manage the energy crisis well. Now, just to give you an idea, and this is important to know, that almost 50% of our fuel is spent on cars and the transportation sector. And you all know the issue of jams and traffic jams and cars and one driver in our cars. This is a big issue. So we always say this was presented to the Prime Minister last year. I personally presented this to him. And I also told him that if you intend to do nuclear energy in Jordan and you want to spend $10 to $20 billion on that, you must give the transportation sector the same share. Otherwise, this is not fair. You will not solve any problem because all the nuclear energy you're going to do is only 16% of the energy crisis. So it does not make a solution. Actually, it will be a burden to the economy in the future because it's a very high technology. So just keep in mind this figure. This will help you also to remember how things are worked. So electricity is a big share. That's why we usually care for the electricity. Now, saving energy. Suppose that this university wants to do an energy audit, and this is what I do in my office anyway. First thing we have to look for is to save the energy before we start thinking of renewables, because we start thinking of anything else. You cut down on your electricity costs, you change your bulbs, you increase the efficiency of your pumps, you increase the efficiency of your heating or cooling systems, and that's step number two. Number three, you start thinking about passive design. How can you shade buildings? How can you protect them from the sun? How you can absorb the sun in winter? That's what we call passive design. And I was promised by Dr. Abdul Karim to be invited to a lecture to talk specifically on green buildings, because this is what I do. And one of my books is called Green Buildings, and it was published in the Emirates last year by مؤسسة. So energy is everything. Everything around us is connected to energy. The water you drink is connected to energy, because it needs purification, it needs pumping. So energy is the core of our interests. So all you people who work in the different sectors, their focus has to be at some time connected to energy. To have a look at the electricity consumption in Jordan also will give you an idea which sectors we should start first. And you can see in underdeveloped countries like Jordan, households are very important. Maybe in developed countries you would look for industrial and households as well. But in Jordan, this is a very high consumption. So I wish that there would be plans for reducing energy costs in buildings, and unfortunately, قانون البناء الوطني الأردني started in 1993, and up till this very moment, and I've been involved in this, up till this very moment, there is no mechanism for enforcing these laws. These are excellent laws, our codes are very good codes, but unfortunately, up to this very moment, there's nothing really substantial about the application of these laws. Maybe you guys can take the initiative in the future to do something about it. And you also know that Jordan is very rich in irradiation. Sun intensity is very high. It's almost 3 times as much as it is in Germany, for instance. And you know that Germany, now you will see that last year and the year before, they achieved something up to 60% of their electricity needs from the hybrid system of wind and solar. Actually, last May, they produced something like almost 70%. You will see the figures now. But what is really depressing is simple solar panels like these to warm up water. We call them solar thermal panels, have been retreating in the past 20 years. IDAMA has made a research in 2011, and they showed that although our energy strategy of 2007-2020 has recommended 25% of households in 2015, actually in 2011 they went back from 15% to 11%. So there is not much interest there. I don't know why. These things have to be researched. You can see the production of these solar thermal are really at its peak in countries like China. So, but you also see that Turkey and some other countries, including Germany, where the intensity of the sun is much less, you will find great production. You can see in million square meters. So it's unfortunate, like a country like Jordan is not, Israel is 80%, Cyprus 85% of their households have solar panels. So this is an issue to think about. Of course, you know about the evacuated tubes as well, the evacuated tubes for solar heating. Now, they are very efficient in winter because there is a vacuum between the two tubes. So if the sun goes, the water will still be heated inside. While the flat plate panels are good in warm areas, but in Mádba, Amman, Ajloun, Salt, these cold places, they will not hold hot water in winter. So the evacuated tubes are very efficient. And you can also see in red the countries that have started to invest in evacuated tubes. In my future lecture about the green house, I will show you how we used evacuated tubes to provide 100% of the houses, which is 600 square meter house, 100% of its energy needs from evacuated tubes. So you can see now the world is going for photovoltaics. This is not something to joke about. This is very serious. I will show you numbers now, how things are developing. You can see in California, California is around the same level as the North Africa and the Middle East. So they have high intensity also, you can see there. And this is in Japan, the lower picture in Japan after Fukushima accident. I'm sure you're well aware of 2011, March 11th disaster of the 4 nuclear plants that they melted in Fukushima. And actually I will take the opportunity to tell you a little bit about this because I visited the nuclear plants last month in Japan. So I've got some pictures for you. So Japan now, they used to depend 30% on their electricity on nuclear. After Fukushima, they made very stringent laws and mandatory laws to reduce consumption. So they reduced 18%. So they still had 12% to go. So they started with voltaics. So in 3 years, they have done 12% of their electricity from photovoltaics. Parts of them are in the sea, as you see, because the land is very tight in Japan. We have great potentials for this, but of course you know that Jordan is limited sea fronts, and I'm sure this is the CSP system. I'm sure Professor Ayman will tell you about this later, so there is no need. But I would like you to know that these systems are very safe, quite cheap, affordable, compared to 2008 prices. Actually, the prices today are only 25% of the prices which were in 2008. And that was the time when I installed PV on my greenhouse. So they are reachable prices. This is Petra, Mahmiyat al-Petra, which it was a loan from the Japanese. Actually, it's not a loan, minha, from the Japanese, yeah? And the solar panel arrived in Aqaba in January 2013. By September, it was finished. So this is a nice example of photovoltaics, how we can do them for our project. So we got rid of the diesel problems inside Mahmiyat al-Petra and so forth. This is the hybrid system of Germany that I told you about. Look how beautiful it is. This is October the 1st, October the 2nd, October the 3rd. The red line is the solar production. So you can see it's at peak during the noontime. And the blue line is the wind production. So they both hybrided to a peak of 59.1% on October the 3rd, 2013. So you can see the potentials in a hybrid system. You can see the potentials in solar. This is in Germany. So you can imagine how much we can do in Jordan. This will give you a clear idea. This is information that I collected and added up. I've done this at my office. You can see, let's start with the solar PV, which is the yellow line. You can see there is around over 100 gigawatts around the world. While 10 years ago, let's say there, we had almost nothing. So you can see the progress every year. If you don't see this exponential curve, that means there is something wrong in our vision and perspectives. You can also see how the nuclear energy is dropping down after Fukushima. Yes, there are some nuclear plants being built around the world, but most of the existing plants are old plants. So they will be decommissioned very soon.
This is the predicted.
Yes.
The red dot on the right.
Yes, 2000. Which one? No, this is this is the arrow, you mean?
Oh, it's an arrow.
Yeah, the arrow is, yes, it's the predicted future decline of nuclear production. Yes. All the other numbers are factual numbers. Actually, now we have developed 2013 because the REN energy report is being published. It's already published. It's in the web. So you can tell the 2013 and 14 numbers. The future oil issue is also at stake. Resources are depleting. That's why you see countries like Saudi Arabia now putting targets for renewable energy and also for nuclear energy. But they are balancing things out. Like they want to do 17 gigawatts of nuclear energy by 2032. At the same time, they are targeting $109 billion for renewable energy to produce 41 gigawatts. Imagine the number. So the Saudis are on the right track, and the Emiratis are on the right track. For wind, you can also see an exponential curve for wind. So now we are producing what, about 300, 2012. Now 2014, it's 326 giga. So also wind is a very progressing field.
Can you just compare that to Jordan production for the
Yeah, Jordan, our peak load in Jordan in electricity term is 3.2 giga. So you can see 3 to 300. Yeah, it's 100 times our needs. As Dr. Ayman always says that only 20 square kilometers of Jordan desert will suffice Jordan's electricity for the coming 10 years. Only 20 kilometers, 20 square kilometers. The many private people own this amount of land, just one person or two persons. So it can be a private investment. So you have, I'm not going to tell you why we don't invest in this. This is up to you to think about it and seek reasons, because this is not a political lecture. This is a scientific lecture. It's up to you to make your own postulations. Many countries in the world are achieving these figures. Look, and this is in 2013. These numbers are jumping. Now Scotland and Germany is seeking to be 100% renewable energy. تخيلوا 100%. Usually we compare things for jobs. We always look for jobs as well because we have a problem with jobs, unemployment. So all these are compared with terawatt hours. Terawatt hours is the quantity of electricity we produce. So every terawatt hour we produce from the different sources, you can find how many jobs they offer. And there again, I'm not going to read the numbers for you. You read them and get to your own conclusions. Mining is a very polluting industry in the world. All mining, you can see the phosphates in Saifa, in Al-Hasa, in Manajim Al-Abyad. كأن على القمر بتمر من هناك كوارث بيئية. So mining has destroyed Africa, many parts of the world. Even East Germany, from the earlier Soviet Union. Now Germany pays 1 to 2 billion euros yearly to manage the waste, the tailing waste of uranium mines which were opened in East Germany by the Soviets. So these mines are very polluting to the air, very polluting to the groundwater, very pollutant industry with radioactive gases and radon gases that will stay there. And some of the radioactive material, like plutonium, is 24,000 years half-time radiation, half-life radiation. So it's a great danger. And the cost of nuclear is the most expensive since 2007. So you can imagine, and that's why no more private investment in this sector has been done since then. Now governments do that. Why? For many reasons. So this is as close as we could get to Fukushima. This is a picture of the plant from like 2 miles away. You can also see the Japanese were very lucky because most of the wind took all the radioactive material away into the sea, but some of it went on land. This little bit of it that went off land, it extended to 40 to 50 kilometers. Some areas are 40 kilometers away, nobody lives there. مدن أشباح. And this is 4 years after the accident. We visited it on March 11th, 2015. The accident was on 2011. And you can see on the right-hand side, the red areas are areas where the radiation level is very high. Very high means 50 millisievert per year. Nobody is allowed to live there. The yellow ones is the ones that are cleaning up, and it's lower activities. The green ones, they say they have already decontaminated the area, and they are asking people to go back, and nobody is going back because they are all afraid. So this shows you the Geiger that I have in my. When we passed by the Fukushima, it was reading 26 in the bus and behind the glass. And this road, you're not allowed to stop there. ممنوع. في شرطي كان معانا. You cannot stop there. You have regular. It should be below 10. Actually, now they say even below 5. But بدهم يرجعوا الناس لبيوتهم. Yes, millisieverts. They have started to decontaminate the soil. تخيلوا تربة لعمق نص متر بجرفوها بحطوها بأكياس. They pack it and just leave it there. مش عارفين شو بده يسووا فيها. They don't know what they're going to do with it. And this is Japan, 4 years after the accident. And now they are building incinerators to burn contaminated wood, contaminated clothes, كل هالشغلات هاي. They're still building it. Look how huge it is. And the people are against this because they say even with incinerators you're going to actually complicate issues. If it rains, it's going to come back again. They have cleaned up the valleys. They can't clean up the mountains. كلها غابات. It's all forests. بطل في حيوانات هناك. بطل في عصافير. اللي سمع بالenvironment عن كارسون ريشل كارسون لما كتبت كتابها The Silent Spring بالستينات 1962 something similar to that لما بلشوا they used DDT as for yes insecticides they killed all the birds so she wrote a book called The Silent Spring طلع الربيع وما سمعت صوت العصافير. It's a very famous book. If you like to read it, it's nice. The Silent Spring. There are cities like this where you cannot enter. هيها شايفين blocked. This is the bus that took us there. There's nobody there. We just drove into it. And you can see all the waste. And civil engineers can see here how the tsunami struck this building. And you see because the columns were sort of thin, so the horizontal thrust was low, so they stood the impact of the tsunami. This happened in Indonesia as well, if you remember, during the tsunami, where most of the masajid survived because they also had round thin columns and the masjid was on the roof for the shade. So they also survived the tsunamis. All this rubble is contaminated. They still don't know what to do with it. All this concrete is contaminated. All the cars that were hit by the tsunami are left there. They don't know what to do with it. شو بدهم يعملوا فيه? They cannot do steel from this like we did during the Iraqi war. Jordan was importing some tanks which were radioactive. They were hit by depleted uranium missiles from the Allies, and they actually burnt it and used it in steel. And when we asked to do some checks on this, they did not allow us to do. But usually they are hidden in concrete. The radioactivity is low, so it's nothing to worry about. These are also, you can see, it's a deserted area. شيء بحزن يعني. Again, there is a psychological impact. You can see Geigers all over. So every time you walk, you look at the Geiger. How much is the reading? If it is high, you leave the area. Even food. They asked us to check the rice everywhere we go. So you can see me, أنا حطيت جريدة وخبيت الجايجر لأنه بيستحي الواحد بالمطعم. هاي صاحبة المطعم كانت موجودة. فحطيت الجايجر تحت الجريدة ومجر the radiation of the rice. بصير حالة من الرعب. فالواحد يعني بشكر ربه اللي بيعيش في منطقة على الأقل low radioactivity فيها. They check everything. This lady checks food. She goes to the stores, to the restaurants, takes samples. So it's a big workshop for radioactivity. And these are the refugees. There are almost 140,000 refugees. They have left their homes. And the government have to educate them, have to care for them. And this is a French professor. he was giving us an example from a French nuclear power station about if an accident happens, where you're going to evacuate. This is the evacuation plan, where you're going to evacuate people. So this is, he's saying when we went to the depot of the evacuated place, we only found that amount of food. So he was wondering how 10,000 people in that village will survive on this. And they have already managed to have 300 buses to carry the people for the evacuation. This is France, remember. And when they phoned, تعرفوا هدول مش زينا، فتح التليفون numbers names فلان فلان مارك جون أبصر شو أنتم موجودين. Yes, he found from the 300 bus drivers only 10 that they were ready to drive the buses. So you can see the issue of evacuation as well concerning the nuclear problem. This is the last slide, so we can open some questions. I'm sorry I did not speak enough for the civil engineers, but I promise you next time I will. This will show you the effect of iodine 131, which is only a few days half-life cycle, that traveled to the United States. And these are the reference from the Journal of Pediatrics. During the few days of radioactivity, when it reached, actually it took 48 hours to reach there, the thyroids of the babies inside their mother wombs were affected. And this will affect the mental status of children. This is this have raised by something like 16%. It was greater than the readings in other areas in the United States. So I will stop here, and I would like to listen to your questions now. Thank you very much. طبعا ضوء بس.
Thank you, Dr. Ayub, for this very interesting seminar, although we did not hear much about the energy crisis in Jordan. But I think we all know that there is energy crisis. So I will open the seminar session for Dr. Ayub, and I will let him manage the questions.
Yes,
and
okay, thank you.
meanwhile, I have to do some work on that.
اوكي تفضلوا. يلا بدي اسمع من الطلاب، انا مش جاي لهون تسمعوني بس. تفضل تفضل
احكي ميا
تفضل. لا
سعد
احكي
سعد
بدون ميكروفون. تفضل.
اسمك و
Obviously, all the numbers and all the figures and all the cost-wise, everything financially and scientifically supports the idea that we should install and recommend renewable energy. So if only, if we're to think of solutions, it's only some sort of either monopoly of some companies that are taking over the energy, or some political issue that we're not aware of that's preventing us from, installing these renewable energies. But what can we do, for example, as freshly graduates, to solve that issue, since we're not in a position of power, neither financially or politically, as recent graduates. So what do we do? Thank you.
Yeah, if we take a spectrum of countries that are pushing let's divide the world into the old world and the new world. The old world, since the 50s, 60s, and 70s till 1989, were preoccupied with making bombs, making nuclear weapons. And that was the main purpose of nuclear engineering at that time. It wasn't electricity. Electricity was a bypass, something subsidiary. It was nothing main. And that's why they built experimental reactors as well, to test. So now, the countries who are doing experimental reactors are only 4 countries in the world, and Jordan is one of them. They are building a nuclear reactor at Just University, unfortunately. They have been doing it for many years. They have made many, many mistakes, and the studies are not complete, yet they are pushing forward. That's okay. To me, that's no problem. If it is for experimental reactor to teach students, that's okay. But to build a nuclear power station with Russian help in an area where you have Daesh on the doors, in an area where our water is so scarce and any pollution will pollute water, because the Azraq water basin, the new location, is near Amra, near Qusayr Amra, which is 20 kilometers from Azraq. Actually, it's 45 kilometers from Amman's airport. And I don't know how many kilometers to Mádba I had in mind to Google it, but I don't think it's much further than that. So how can you manage these things? That's why I say this is a project that supersedes, that transcends any economic needs. It has a political dimension which I'm not aware of.
I'm sorry, just if you don't mind me interjecting this. The idea is simple. For example, why are we not, LFI dam, for example, على خبز per se, LFI dam improvement, for example, على شرب.
Thank you. Yeah, your message is here, but I'm not the right guy to ask this question. Ask your MPs. تفضل.
Thank you very much. You said in your first slide that you showed it to the Prime Minister, and obviously from what you're reading and hearing that the government is still insisting on creating that power plant. What is the argument? Like when you show the slide and the numbers, what was his reaction? What's the counter?
I think our Prime Minister knows very well this is not a priority for Jordan. I think he knows very well. He's a very intelligent man. He knows very well this is not a priority. But I don't know what to tell you. There's so many things are involved. Maybe Iran issue, maybe, I don't know. It's a complicated Middle Eastern connections, political more than as I said, financial. I think, no, they will stop. They will push forward for a while. They will do the studies, and I don't think the Americans will allow the Russians to have a base in Jordan like this. I heard it more than once. But they will go ahead with it for a while. زي كل المشاريع الباص السريع وانت عارف. أيوة. Let's have more questions, please. Direct questions from my presentation. تفضل. Yeah. Some radioactive isotopes have a very short half-life. Some of them minutes, some of them years, some of them hundreds of years, some of them thousands of years. And the radiation they emit is different. Could be alpha, beta, gamma. And each one is a complicated issue. Alpha does not affect you from outside, but it affects you if you eat it or inhale it. Like the depleted uranium. When they destroyed مطار بغداد, تتذكر بالحرب 2003, they used depleted uranium on the tanks, which it's depleted uranium is U-239, which is part of the nuclear waste industry. They extract it from the nuclear waste, and it's a very heavy metal. It's 1.7 times heavier than lead. And when you put it on a bullet or a missile or whatever, it makes it heavier, and the piercing ability is very high. It raises the temperature to 3,000 degrees. So it melts the tank. So, yes, I hope that would answer your question. Next. يلا دكتور تفضل.
Saad asked the question, what can the new generation do to help in this solving this issue? Yes, thank you. Okay. You can help your country and the world, because Jordan is not isolated from the world. If you support renewable energies at your home, if you reduce your consumption at the university and at your home, you are helping the environment and helping your pocket and reducing the electricity load. This will not give them the opportunity to make an excuse to build extra power stations. Last week, they opened the biggest electricity generating
in المناخر turbine 570 megawatts, which is more than half a nuclear power station, by the South Koreans, by the Finnish, and by some other, I think, the Japanese as well. So there are alternatives. So what you can do is do your research in the university on these things. Try to go into this line of renewable energy. Try to find out green solutions for your university, for your home, and then when you graduate, for the country as a whole. I think learn more. Today you have all the means that you need. Your computer, your Google. You know, I can make lectures now in 2 days. I'm going to Saudi Arabia next Sunday, and I prepared my lecture in 3 days. So much information. You just want something about Jordan, you find it. Saudi Arabia, you find it. America, you find it. So make use of this وسيلة التعليم, which is very useful. Is that a good answer? Thank you. Thank you. Yes, sir.
Let me first of all introduce myself. Maybe some of the students don't know. I'm spending my career at the University, from the University of Baghdad. But my previous one was with the Iraqi Atomic Energy Commission. 10 years on the industry. Just an explanation concerning what I just in mind. Why Jordan seeking for the nuclear energy for experimental results? You know, there is so many aspects that nuclear energy could be used not only for the power generation and for the fossil plants, but for the research. And one of the plans was at that time during the early 80s when Iraq decided to build a nuclear reactor from France, supposedly Sandizi's, was to form a material testing reactor. And the nuclear energy could be useful also for the medicine and industry, and most of the medicines related to the radioactive materials was produced in Iraqi nuclear reactors. So my, let us say, expectation that Jordan may be trying to build a material testing reactor for...
Yes. Yes, thank you. Well, I actually would answer this question in 2 dimensions. First dimension, look what happened to Iraq because they were started to go nuclear. So the West and Israel in particular will not allow any such thing to happen on their borders. نضحك على بعض. هذا أولا. ثانيا, adjust. They already have a subcritical reactor built by the Chinese. It was decommissioned in 2013. So if they want to do any experimentation, they can do on that. What do they need with the South Korean reactor? It's just wasting money. It's 130 million, plus now they ask for 42.5 more, and they haven't finished it, and they will take probably 5 more years to do that. So they're spending so much money on it. As for research and radioactive isotopes, which is used, of course, in the industrial, you can buy them. In the past, the Libyan reactor in Libya was supporting half the world with the radioactive. You buy them. Jordan only spends 500,000 JDs every year on these radioactive isotopes. We are importing cars. We are importing everything. صفت على هاي الشغلة. I don't buy. These are good ideas, but I don't buy it for Jordan. Yeah, thank you. One last question. أيوة تفضلي. لا ما هو بدنا بنت تحكي يعني كلها شباب. أنا مش طالع من هون قبل ما بنت تسأل سؤال. مش طالع هيني واقف. وين حقوق المرأة؟ وين اللي بتطالبوا بحقوقكم؟ اسألوا بس بدكم تاخذوا أعطوا. تفضلي. Sorry? Yes. That's plutonium. That's not uranium. Uranium 238. Yeah. What's ما هو في كتير عندك uranium. عندك 235, 238 بالضبط. Yeah. Plutonium. Yeah. Uranium 238. You're right. But Google plutonium. Of course, هو radioactive material is different زي ما حكيت. في عنا iodine, في عنا plutonium, uranium, كل الأنواع. عندك كتير أنواع. في إشي yes billions of years. So it will be contaminated, you're right, but these quantities are very, very small. Usually they just hide themselves in nature. إذا بنزلوا على المي بترسبوا بروحوا بيدخلوا بالدورة الغذائية بس what we are concerned is cesium, for instance, is very rich in these explosions. So cesium 137 has a half-life time of 30 years. This is the most contamination in Japan now. But as you said, there are other types of uranium and plutonium and which stay there for a very long time. Yeah. على البحر. Yeah. رح ناكل انا وياكي سمك منه لانه السمك بيمشي في فكرك انت هاي دورات المياه اللي بتمشي في المحيطات هاي دورات بتوصل لافريقيا وبتطلع للشمال. Of course it's like Chernobyl 1986 a friend of mine he used to be at the دكتور علي المر اسمه كان مسؤول عن الاشعاع في مديرية الاشعاع في وزارة الطاقة. Yeah, in the Ukraine. In 1986, the radiation arrived to Turkey and northern Syria. And شحنة بندق وصلت على الأردن radioactive. And he told me that they checked it and it was radioactive. So this is England. Some parts of England were polluted by Chernobyl explosion. So this is a worldwide, yes, it's a worldwide problem. تفضل.
Can I ask a question?
Yeah.
Okay.
My name is Hussein Kiswani. I'm from فريدرش ايبرت. I'm the program manager of the climate and energy policy. So, Doctor, I would like you to, it would be great if you shed the light on the global perspective and why we should transform to the renewables and change our the use of fossil fuels. Because you didn't mention that in the presentation, and I would like the people to hear more about why should we and what is going on the global scale. And how
okay, thank you. So we have a climate change problem. The climate change problem has to do with gases, right? Warming gases like CO2, CH4, N2O, and hydrofluorocarbons. Tamam? What produces these? Fossil fuels. What are the alternatives? Clean energy. Now, they say that nuclear energy doesn't produce. You have seen how many millions of years this radioactivity stays. And also, nuclear energy depends on mining uranium. Mining uranium produces a lot of CO2, but they don't calculate the CO2 they produce in mining. They only calculate the CO2 they produce in the nuclear power stations, which is 66 grams per kilowatt hour, compared to 250 for gas, for instance. But if you add the pollution that happens during mining, it's the most pollutant industry in the world. So the only alternative is clean energy. It's cheap, it's quick, it's safe, and it produces jobs. زي ما انتوا شفتوا. شو بدنا أحسن من هيك؟ بعدين it's sustainable. The idea of sustainability is there. Uranium mines only have the capacity of 3 million more tons, and they will deplete. Fossil fuels, they will deplete. The only thing that will be sustainable in the future, you the engineers of the future, the only sustainable thing, if you want to work, if you want to have good jobs, it's the renewable energy. Thank you.
I cannot thank you enough, Dr. Ayoub, for this very intricate and an important lecture about the energy situation in the world and what is important in the energy mix. So right now let me introduce myself and talk about one aspect of energy that all of us, we have heard about in Dr. Ayoub's presentation, which is renewable energy. And in particular, I'm going to talk about one application of solar energy that we did in Mؤتة University, and a project that won international prizes and have 4 patents out of it, was utilizing a concentrated solar power which is one type of solar energy to produce electricity, water desalination, cooling and heating. That project was actually funded by the Jordanian Scientific Research Fund under that number shown here. It was done in Mota University, which is 120 kilometers. Actually, from here is about 100 kilometers to the south. And this is the third oldest university in Jordan, and the second largest. The idea came from this point, is that we use solar concentrator, which is to concentrate solar energy and to store solar thermal energy, which is much cheaper and more easier to store than electricity, to generate steam for industry or to generate electricity from that steam. And the steam coming out from the electricity goes into water desalination, and the heat rejection from water desalination runs a patented chiller that runs on heat, not electricity, as we will talk about. In summer, so we generate cooling in summer and we generate heating in winter. That was the vision, and actually that what achieved. This is a three-dimensional presentation of the system that we had. This is the solar field collector, and we will show you actually some videos. The solar field collector, these are heat exchangers to generate the steam, to run the steam engine here. Oh, it's not showing. This is the steam engine. That is not showing. Okay? We didn't have pointer. So this is the steam engine here. This is steam generator. These are chillers. So we generate cooling, electricity, water, and heating. Let me show you some videos before you guys lose interest. Okay. Let me show you some video about the system. This is parabolic trough system, and they track the sun. This is parabolic mirrors that they concentrate the sun on the middle and generate oil 260 degrees. And as we can see them, they track the sun from sunrise to sunset. I can show you here that this as they heat oil to 160 degrees, they can operate a steam engine by opening this engine is run by a steam generated from solar energy. And let me show you some steam actually as we show it here. Okay, let me repeat it back again. So you can see the steam generated. This steam is used for industries. Many industries uses steam. So that steam is generated from industries. There is something I call burning the stick test. Is the first time we made this parabolic trough. We put a stick in the middle. And as you can see, within seconds from taking the, let me repeat this video again, please. Within seconds from taking the blanket and allow the solar rays to get to it, this stick burns. Seconds, only a few seconds. Okay. So let me go back to the system again and talk about it. As we have seen here, these are the collectors that generate the hot oil. The hot oil comes here, generates the steam. The steam comes in into the steam engine, generate electricity. The steam from the steam engine desalinate water. The heat from the water operate the chiller in winter and used for heating in summer. Sorry, operate the chiller in summer and were used for heating in winter. This is the thermodynamic cycle for our students, for our engineers in mechanical engineering, which are most of them here. But we'll talk about it later in the classroom. The system highlight, this system produces 120 kilowatt thermal of peak from parabolic trough. Thermal oil is heated to generate steam at 210 degrees centigrade. 220 horsepower steam engine is connected to electrical generator to produce 15 kilowatt of electricity, 150 liter per hour of water, and is generated 20 kilowatt of cooling and 80 kilowatt of heating. That was built on the top of the engineering Faculty of Engineering at Mota University. This is the photo here before, and this is the photo after we installed this parabolic trough concentrator. We went to the draw shop. It's a lot of engineering. We did a lot of engineering into that. That is our work here. This is the layout of the oil cycle called the BNI diagram. And these are this is the chiller cycle. That operation was done into cooperation with so many international companies. Ryer supervised that. There is Mike Brown, the U.S. company that provided the steam engine. Sobogy is the U.S. company that provided the parabolic trough. The Bales, the German, and Millennium is the one who did the chiller, which is my own patent. The collectors came like that. They are pieces of metals. And we actually had them build a tent on the roof of the mechanical engineering, of the roof of the engineering, and we built these collectors one by one. This one here is the American engineer who came to supervise our work to make sure that it is according to their foundation. We did that with a lot of also civil engineering involved. For foundation, we use something called chemical bolts and for the bases. And this is the result of burning the stick test we talked about. And then the system starts taking shape to look finally like that. That system tracks the sun. We reach in winter 230 degrees and in summer 265 degrees, that is winter. And we measure it in so many ways. This is a photo of the power block. This is the oil, the steam generator. This is the steam generator. This is the steam engine. This is the desalinator. This is the three-way valve controlling the flow of oil to the steam generator. This is some outcome. We produce actually 130 kilowatt instead of 120, and this is the electricity generated. Water desalination, chiller. We can see that we reached actually to 3 degrees centigrade of our chiller, which is actually my own patent, manufactured in Jordan. The steam engine, this is the chiller. This is as it's stripped out from its outside, and this is how it looks in a commercial way. It's now commercial. It's an air dry chiller, which is the first of its type in the world. The patents, this is the chiller patent. It's registered in 32 European countries, and in the US, and in Japan, and in China, and in Australia. All these patents, two things. This is the payback period for that system. The payback period is if the oil prices is like 70, the diesel price is 70 piastre, the payback period is like 3 years. The system is really economical. And here the thermal storage system that I will be talking about it very quickly is we stored heat in form of thermal storage in which we melt the certain salt. We melted and we stored the heat in forms of melting the salt. The experimental setup was done by a PhD student. We have 3 PhD students working on this system. And this is the result. So that was the vision, and we realized it, and thank you very much. So open for questions. Yes, Dr. Ayub.
I would like to inquire the cost efficiency of such a system compared to photovoltaics, and why is not this CSP prospering over the world?
Yeah. The main idea of this system is we are not using CSP for electricity generation alone. For electricity generation, we cannot compete with the PV at this time. Of course, when this system was started to build, it was in 2008 we start applying, when the CSP was more economical than the systems, than the PV. But even now, if we calculate the energy to do all of these, the cascading process, not only electricity generation, because we use this collector not to produce only electricity, we produce electricity to produce water, to produce cooling and heating. And if we calculate, if we're going to generate all these with PV, this is even more competitive and this is on an experimental scale. Imagine when it comes into a commercial scale. But for electricity alone, the PV is much more competitive than CSP. Okay, please. It's actually, the civil engineering has a very big role in that, because the construction, as you can see here, and as you've seen in the video, when the parabolic trough turns and faces the sun, either sun, east or west, it acts like a sail. The wind load on it is huge. That's now we are developing another system called the Fresnel system. We have much less wind load. So the wind load is really low in that. But here the wind load is high, and I showed you some slides there about the civil engineering for the design. And actually we use very, very special designs, and we use something called chemical bolts, something not very new in Jordan. It's not well known in Jordan. These special things and the bases and the foundation calculate, and the structure actually. The structure and the design of the parabolic trough has a lot to do with, it's a steel structure. Actually, civil engineers participate a lot of it. So the civil engineers actually have a lot to do with the designing of these systems. Okay. 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 Last question before. Yes. Further. Well, the motion we've seen in the video is really accelerated very much. This motion is less than ticking of the clock. You really don't notice it. Is maybe every minute, every 20 seconds, 30 seconds, it's 1 degree. So it's not really a lot of energy for that. It's the energy it's calculated in the net energy. And actually, the motion is taken from the electricity generated by the system, and it's not much of using. Yes. Automatically. It has a GPS track. Let me show you the video again. But again, here, this is accelerated. This motion takes place over 1 day, over, let's say, 12 hours. What you see in a few seconds here. So it tracks the sun automatically by calculating very accurately the solar position and the solar angle, and what it should be to concentrate the solar beam on the heat fluid pipe, which is that pipe there. Okay. Any questions? Thank you very much.